All right, let's jump right in today. We're going deep on wireless networking.
Yeah, definitely.
But not just the basic stuff. We're talking CWDP-305 exam level.
Right, gotta get you ready.
We're going to break down real exam questions, figure out not just the what, but the why.
Yeah, like the thinking behind it.
So you can crush that exam and also, honestly, walk into any room and just know its Wi-Fi situation.
Exactly, that's the goal. Not just passing, but really getting it.
Okay, so first up is question 1, signal propagation. What messes with Wi-Fi strength the most?
Oh, this one's good. It's all about, well, what our buildings are made of. Makes sense when you think about it.
Totally. I wouldn't expect great cell service inside a rock concert.
Yeah. It's like that. Materials affect radio waves, just like they do with sound.
So, concrete wall. Basically, Wi-Fi dead zone.
Pretty much. That's attenuation. Concrete, metal, they're signal blockers. Drywall, not so much.
Got it. Which makes question 2 about site surveys super important then.
Oh, yeah, for sure.
It's like scouting the land before you build your Wi-Fi camp.
Haha, perfect analogy. You measure signal strength, find those interference sources, and figure out where to put those access points.
Speaking of interference, we all know about other Wi-Fi networks.
Oh, right. Those are obvious.
But you mentioned non-Wi-Fi stuff too. What even is that?
Oh, tons of things. Microwaves are notorious, old cordless phones, Bluetooth, anything. Fluorescent lights even.
Wow, so many hidden Wi-Fi enemies.
You said it.
Okay, on to question 3. And this is about antennas. The things that actually send out the Wi-Fi signal.
Right, the broadcasters.
The question's all about choosing the right kind for different places. So, what are our options?
Okay, so you got your omnidirectional ones. Those are like sprinklers sending signal everywhere.
Makes sense.
Great for general coverage. But then there are directional antennas like Yagis, patch, sector antennas. More like a focused water stream.
So if you try to reach a distant building or something.
Exactly. Think about watering a long, narrow garden. Sprinkler's going to waste water.
True. You'd use a soaker hose or something.
Exactly. Directional antennas work the same way. Put the signal right where it's needed.
Smart. Question 4 brings up this scary-sounding thing called co-channel interference. CCI. What's that all about?
It sounds complex, but picture this. You got a room full of people, everyone talking at once.
Uh-oh. Recipe for a headache.
Yeah, that's CCI. Multiple access points all using the same channel. Nobody can understand anything.
So how do we prevent our Wi-Fi from becoming that party?
Channel planning is key. Assign different non-overlapping channels to your access points. It's like giving everyone their own space to talk.
Got it. So 2.4 gigahertz. Are there specific channels that are good?
Yeah, the classic approach is using channels 1, 6, and 11. That way they're spread out nicely.
Nice. All right, question 5 takes us to high-density WLAN, so places packed with devices.
Oh, yeah, think a busy office or a convention center, tons of people online at once.
How do we make sure everyone gets a piece of the Wi-Fi pie in those situations?
5 gigahertz is our savior here. Think of it as a much bigger room, way more space for everyone to talk.
Okay, makes sense. More channels means less stepping on each other's toes.
Right, but even with 5 gigahertz, we got to watch out for channel width. Those super wide ones, like 160 megahertz, they can offer amazing speed.
But there's got to be a downside.
Well, they're also more prone to interference, like trying to have a private chat in a loud room. Wider bandwidth means picking up more unwanted chatter.
So it's a trade-off. What about those times when you're setting up near an airport or weather station? Question 6 mentions something called DFS.
DFS. Dynamic frequency selection.
Sounds complicated.
It's about playing nice with radar systems. Basically, if your Wi-Fi detects radar signals...
Which near an airport makes sense.
Yeah, it'll automatically switch to a different channel, like yielding to an ambulance. Gotta be safe.
Gotcha. So knowing about DFS is crucial in certain locations.
Absolutely.
All right, question 7 is all about band steering. Is that like Wi-Fi traffic control?
Haha, pretty much. It intelligently directs devices to the best band for them.
Okay, I'm intrigued. How does that even work?
It's like having a smart traffic cop guiding cars to the less congested highway. Keeps everything flowing smoothly.
So it's like a matchmaker for devices and the 5 gigahertz band.
You got it. Keeps the 2.4 gigahertz open for older stuff, while newer devices get that sweet, sweet 5 gigahertz speed.
Efficiency is key. Question 8 is about voice applications, like those real-time calls that need perfect audio.
Right, crystal clear.
What's the secret sauce for making WLANs work great for voice?
QoS, my friend, quality of service. Voice traffic is super sensitive to any delays or interruptions.
Like those choppy phone calls that make you sound like a robot.
Exactly. QoS prioritizes voice packets, so they get VIP treatment.
Makes sense. Got to keep those conversations smooth. Now, question 9 talks about post-deployment site surveys. Why check up on the network after it's already running?
Think of it as a final inspection. Make sure everything's running smoothly, signal strength is good, no sneaky interference popped up.
So like a regular Wi-Fi health checkup.
You got it. Catch those potential problems early.
Makes sense. And lastly, question 10 brings us back to 2.4 gigahertz and interference. This time, it's all about Bluetooth.
Uh-oh, the little guy causing trouble.
Yeah. Why is Bluetooth such a problem child on 2.4 gigahertz?
Well, Bluetooth and Wi-Fi, they're both trying to use the same frequency range.
Oh, right. That's going to cause issues.
Yeah, and Bluetooth uses this thing called frequency hopping spread spectrum, or FHSS.
Frequency hopping? Sounds like a dance move.
Haha, it kind of is. Bluetooth jumps between different frequencies really fast.
To avoid interference, I guess.
Exactly. But unfortunately, all that hopping can mess with Wi-Fi signals, causes dropped connections and slowdowns.
So how do we keep Bluetooth and Wi-Fi from fighting?
Simple things help. Keep Bluetooth stuff away from your router. Use wired connections when you can.
Okay, good tips. Well, I gotta say, this has been an incredible deep dive. From the physics of signals, to designing for crazy scenarios, and now even troubleshooting.
Yeah, we covered a lot.
Listeners, you're officially Wi-Fi experts now. You can design networks, you can fix problems, you got this. Thanks for joining us on this journey, and we'll catch you next time for another tech deep dive. See ya.